Hello and welcome, I'm your CodeMonkey. In this lecture we're going to learn about arrays and lists. This is how you can store multiple pieces of data together. Okay, so previously we covered the basic data types. For example, you've got int, bool, string, and so on. The variables are essentially just containers for data. And for example, if you make an int variable, then you can store some kind of int or whole number value. Like for example, the number 56, I can take it and I can indeed put it inside an int variable. However, when I want to store more than one number, so now let's say I want to store this one, nope, that does not work. I can only store one value inside a single int variable. So when you want to store multiple values, that is where arrays come in. You define an array of a certain type, like for example an int array. You give it some sort of size, which is going to be fixed. You define that size when you create the array, and that basically creates multiple boxes, multiple containers on which you can put any kind of data you want of that type. So for example, now on index 0, I can place this value, and on the next one, I can place this one, then I can place this one, and so on. So like this, I can place multiple pieces of data on a single variable. One important thing about arrays are the indexes. Note how the array has a length of 5, meaning it has 5 elements. But for these 5 elements, the first one is over here on index 0, then the second one is on index 1, and so on. So the positions in the array are always index-based and they always start at 0. Using the index, we can individually either set or read values directly from the array. Okay, that's the theory. Now let's see the syntax. The way that we define an array is actually really simple. We define the data type as usual. So for example, let's say an int array where we want to store ints. So we define data type and then open and close the square braces. Important, it is this one. It is not parentheses, it is not curly braces. Nope, it is the square ones. So you do this and yep, that's it. This variable is now defined as an int array. Let's give it some kind of name like numbers array. So yep, this is our int array, and afterwards we can initialize the array, and for this there are actually several ways to do it. If we want to initialize it with some elements, the simplest way we can do it is just open curly braces and inside put any kind of elements, like let's say a whole bunch of numbers. So if there you go, like this we are initializing the array. Alternatively, you can be a little bit more explicit with the type creation. You can do new int array and then pass in all of the elements. Personally, for me, this is my preferred method. Like I said, I like my code to be as explicit as possible, so personally I do like to be very explicit with how I define the array, the exact type that I'm using. Or alternatively, you can simply create an array without any elements and just give it a certain size. Like this, there's an error, you have to give it a size. So for example, let's say with 5, and there you go, this creates an array, the numbers array. This is an array with 5 elements. And like this, if you don't initialize to anything, then pretty much all of the elements will be initialized to 0. So speaking of the size, this actually brings up a very important topic about arrays. Their size is fixed, and after being created, the size cannot be changed. Over here, we are creating an array with size of 5, and that's it, that cannot change. If you want to check the size of the array, we can see that through the length property. And the way we do that is first we access our variable, so that's the numbers array, and then we write a dot, and this dot basically means that we want to access something inside this variable type. And in this case, this variable is an array, so by typing dot, we are accessing all of the functions and properties that exist in the array type. So it's kind of similar to how previously we saw console.writeLine. Basically, writeLine, this is a function that exists inside the console class. That's what the dot means. It means we are accessing something on the symbol previously defined. Okay, so like this, we are accessing something on the array. And if we want to get the size of the array, for that, we can access the property for the length. So if we just do a console.writeLine on this one, just to see what this says, let's see. And if there it is, it says 5, which is exactly the size that we defined for our array. If we modify this to 3 and run, and yep, now it says 3. So the length, this is going to return the size of the array. Then another thing you are going to do quite a lot with arrays is simply accessing them to read an element on a certain index. And the way we do that is we simply write the array, so numbers array, and then we write the square brackets, and inside it we put some index, like for example, let's say index 0. Again, remember how in C# indexes start with 0. So the one on index 0 is going to be the first element, the one on index 1 is the second element, and so on. So first let's initialize the array, so let's initialize it with something. Let's put a whole bunch of numbers. Okay, so we initialize with a bunch of numbers, and now let's print out the one on index 0. So let's do a console.writeLine on that, and let's just get rid of this previous log. Okay, let's see. And if there you go, it does print out the number 56, which is indeed the very first element on this array. However, also something very important is that we actually initialize the array first. And like I said, we can initialize it like this with some values, or we can simply omit this and simply initialize it with a certain size. If we run this code, yep, it returns 0. Basically, the array initializes everything to 0. However, if we don't do this, if we just find the array, then nope, here we have a compiler error. So we need to actually initialize the array before we can use it. And like I said, the arrays have a fixed size. So when accessing an index, that also becomes important. For example, if we try to access after the size, so for example, over here we have 3 elements. If we try to access the one on index 5, which does not exist, if we do this, then yep, we get an index out of range exception. That is because the index 5, that does not exist, that is outside the bounds of the array. Same thing if we try to go the other way. So if we try to go -3, if we do this, then yep, same thing, same error. Now, if we do want to change the size of the array, like for example, if we want to add another element to the array, like I said, that literally cannot be done. The size cannot change. So the only thing we can do is simply make yet another array, add it with one more element of space, and then copy all these elements on the new array and then add the new element. So you'd have to make all that logic manually if you wanted to add an element to this array. Or alternatively, for removing an element, once again, same thing, you cannot change the size, so you'd create a new array with one less length and then copy the remaining elements onto that array. You can manually write that logic with the help of loops, which we're going to learn about in the next lecture. Or in order to add or remove elements to an array, you can simply use a different collection type, namely the list. The list is actually built on top of the arrays and basically has a bunch of helper functions to make it super easy to add or remove elements or do a bunch more things. And to use a list, first we write list, and then we write the angle brackets. So this is a less than sign. Then we write the data type that we want to store in the list, like for example an int, and then the closed angle brackets, so the greater than sign. Again, don't confuse the symbols, make sure you are using these symbols. Like for example, there is a double character, it is not this one, it is the single one, the same one you use for mathematical comparisons. Now the technical term for what we have written here inside the angle brackets, the technical term for this is a generic, which we're going to cover later on in detail in the intermediate section. For now, just make sure you write this syntax exactly. So with this, we have defined the list of ints, so let's call it int list, or actually to keep it the same name, let's call it numbers list. Okay, and then to create our list, we have pretty much the same options we have for the array. We can do the full type declaration, so over here put any kind of values. Yep, this is our list. However, on this one we cannot initialize it just like this. This specific initializer only works for arrays, so for a list we cannot use this one. But we also have the third option of simply initializing a list just like this. And here note how I did not put any number inside the parentheses, whereas over here when defining a new int array we have to give it a size, but for a list, like I said, lists don't have a fixed size, they can grow and shrink. So when creating a brand new one, you don't have to give it a size. Although technically, if we actually inspect this constructor, we can see there is a version that does take a capacity. Now this is a more performance optimization thing. If you know you're going to need a certain number of elements, you can preset that capacity. But in most cases, and especially right now on this beginner section, you can just ignore it, just do it like this and it'll create a brand new empty list. So we have created a list, and now we can do, let's say, the same thing that we did on the numbers array. Let's first print out how many elements are on this list. It's pretty much the same thing, we just access the same number list, except right now on a list, this one is actually not called length. If we find length, we can't find anything, so it doesn't have that name. In length, it is instead called count for counting the number of elements in the list. But in terms of logic, it's really the same thing, so it returns the amount of elements within that list. So let's do a right line on this one, and since we just created, this one should return 0, and if there it is, this one does have 0. Okay, great. Then like I said, one of the big benefits of lists as opposed to arrays is we can very easily add or remove elements. The way we do that is we just access the list and then use the add function, and this one takes an item that we want to add, so let's add the number 12. And if we do this, and afterwards let's print out the right line on the numbers list.count, let's see this, and yep, that one does indeed have one element. And if we access the list on the 0 index in order to see our first element, and yep, we do see our list contains the number 12. Okay, great. So just like this, we can already see just how much better it is to work with lists as opposed to arrays. With this, there's no need to manually create a new arrays with the size +1. We don't need to do that and copy all data. Basically, all of that is handled automatically by the list. We just call add, or alternatively, we go inside the numbers list and we call remove. Either one of these, and we'll either add or remove an element. Over here on the remove, the way this one works is you give it some kind of item. So in this case, the only element inside is the number 12. So if we call 12, this is going to remove the number 12. Or alternatively, there's another one. There's the remove at, which then takes an index. So if we do this and pass in the index 0, it is going to remove the element on index 0. And related to the add, there's also another one, which is the insert. Basically, the add, that one is always going to add the new element to the end of that list. Whereas with insert, over here, you can pass in an index where you want to insert that new element. Another super useful function in our list is for finding elements. Let's add some more elements just to test. So let's add 12, 0, and let's say 89. So we did this, and now let's say we want to find if the number 89 exists inside this list. If so, we can go through the list, and we can call the contains function. And like name implies, this one tests if it contains a certain element. So if we test for 89 and C, and it returns true because it does have that element. Whereas if we put some different number, and nope, does not have that element. Another similar way to find elements within a list is to use the index of. This is basically going to return the index of an item if it finds it. So for example, the index of 89, this one is the third element on the list, so it should return 2. And if there it is, it does have a 2. or if we include something that is not found, so if we include something that does not exist. If so, then yep, when it doesn't find anything, it returns the index -1. Since -1 is not a valid index, -1 usually means not found. And by the way, actually over here on the array, you can also do something similar to this. You can do an index of. However, it's a bit different, so it is not like this .index of. This does not exist. There's no function called index of within the array. However, it actually exists as a static method. Again, don't worry what static means right now. We'll explain it in detail in a later lecture. But basically, we just need to access through the system.array. We access through that, and we can do index of. And this one takes our array, so the numbers array, and then whatever we're trying to find, let's say we want to find the element 1, 2, 3, and if we do a console.log on this, do a write line, let's see. And yep, that one does find it on index 1, and yep, number 1, 2, 3 is over here indeed on index 1. So as you can see, arrays and lists are really excellent, really very useful tools for handling multiple pieces of data. The technical term for these are collections. An array is a collection and a list is also a collection. There's a bunch more collection types for more advanced use cases. You have stacks, dictionaries, hash sets, and a bunch more. I cover all those in detail in a lecture in the intermediate section. For now, just knowing about arrays and lists, it is going to be more than enough. Whenever you need to store multiple pieces of data, you can use either one of these. In most cases, you probably want to use a list just because they are so easy to use. And when you need absolute maximum performance, for that, arrays can be quite useful. Alright, so here we'll learn about something very useful, arrays and lists. You won't be using these a lot in your programming career. And now in the next lecture, we're going to learn about one of the core tools of just about any programming, which are loops. So let's learn that in the next lecture.